Dear students, our next new data structure queue. As name indicates, it's just handled like a normal queue in our daily life. Okay. A queue can be defined as an ordered list which enables insert operations to be performed at one end called rear and the delete operations to be performed at another end called front. QUEUES referred to be as a first in first out list or first in first out data structure. We all know stackers a last in first out data structure, but QUEUES first in first out data structure. So we can serve the very first element that is come to our queue data structure. There are two pointers that is enables the perform insert operation and the delete operation. These are our rear and front. If the queue is empty and rear and front is pointing to the null value or -1 value, this is our queue data structure. So which data is coming as a very first data or first element of this queue only can be deleted first. So let's assume that there is a one element q. It is a character q. So there is a letter q is there. At that time, when only one element is there, the rear and front is pointing to that first element. Then if you want to insert more, it is inserted only at the rear side. So we are incrementing the rear value and we are inserting to this position. Like that, we are inserting the elements. So this all are the datas in this queue. Now the rear is pointing to this position. Front is always there at this time also. Okay, so front is always pointing to the very first element if the stack is not empty, and rear is pointing to the very last element of this queue. If you want to delete an element from the queue, you can only delete the very first element of this queue. So when we are deleting, our front is now pointing to this position. So maybe our value is like a queue data structure, datas or queue datas. So at this time, if the queue is full, our rear is pointing to the very last element. If the rear is pointing to the very last element or very last index, the queue is full. Okay. If we are deleting an element from the front side, let's assume that we have already deleted. We have deleted the element q. Okay. But we are only at the time of insertion, we are only pointing to our rear side. If rear is pointing to the very last element of this queue data structure, even though there is a free space at the front side, we can't insert more element to our normal symbol queue. So now we are going to applications of queue. Queues are widely used as waiting list for a single shared resource like printer, disk and CPU. We can use queue data structure for CPU scheduling, disk scheduling, printer device management. Like that we are using queue data structure. So we want to print more than 5 or 6 files. We can print only the very first file that we want to print first. So we are maintaining a queue data structure for this. For CPU scheduling also, maybe some lots of processors are waiting for the CPU time. Different CPU scheduling scenarios are there, but in many main scenario is first in first come CPU scheduling, that is it is maintained by a queue also, because first process is getting the first CPU time first. Okay. Queues are also used in asynchronous transfer of data. Synchronous transfer means data is not being transferred at the same rate between two processes, not the same time or not with the same rate. So for that, we can transfer the data according to time they came to the network. The data with the first data always to be transferred very first. So for that also queues are maintained. Queues data structure is using. Queues are used as buffers in most of the application like MP3 media player, CED player, etc. Queues are used to maintain the same application as the playlist in media players in order to add or remove songs from the playlist. For this also we are using queue. Queues are used in operating system for handling interrupts. So lots of interrupt handling mechanisms are there. Mainly queue is used as the main data structure for handling interrupts in operating system management. So that is all about the main applications of queue data structure. Thank you.